the mole. We mentioned earlier that if you blew up an atom to the size of a football stadium, right, that the nucleus would be the size of a what on the 50-yard line, you remember? An orange. So it's almost all empty space, an atom is, but they're extremely, extremely small. So if we want to fill a bag like this with some compound, and I mean, you need a lot of these atoms, a heck of a lot, and literally millions of billions, right? And anyway, that number, millions of billions, we'll talk about it, but it's referred to as a mole. Okay, so it's badly needed to be working problems, and that's why we're introducing it. So let's just get started with something a little more familiar, though. Danielle, how many, if you have a dozen atoms, how many would you have? You'd have 12, yeah. If you have a mole of atoms, though, Allison, how many atoms would you have? Is Allison here? Allison's not here, right? Oh, Allison's here, back and back. I was thinking of a different Allison. Starts with a 6. Anybody help her? 6.022 times 10 to the 23rd. A huge number, right? Referred to as, what's the guy's name, Melissa? Starts with an A. Avogadro. Referred to as Avogadro's number. So before, we could write 12 in 1 dozen, right? Or 1 dozen is 12. We've done that. We're going to do the exact same thing with Avogadro now. We're going to say there's 6.022 times 10 to the 23rd atoms in, not a dozen, but in 1 mole. Or you could say in 1 mole, flip it. There's 6.022 times 10 to the 23rd atoms. So that's how we're going to use Avogadro's number. Here's a question, typical question that gets us started. Katrina, how many carbon atoms are in 0.0038 moles of carbon solid? And how I want to handle this, Katrina, is I want to treat this the same way we did when we said, okay, let's convert 10 centimeters to 20 kilometers or something, right? We started with the, where do you start? Well, that's, for example, if we want to do centimeters to kilometers, that's like starting with kilometers or meters, right? We're not so sure should things be top or bottom. But if you start with the measurement, that's how we did it. We start with the measurement. And then things are just logical after that. For example, if you start with the measurement, 0.0038 moles of carbon. Because so much of this course is just converting one set of units to the other. What did we do, Jonathan, with these mole of carbon units? Yeah, well, where do they go? They have to go where? Have to go to the bottom. Right? Yeah, you're right, converting them, but I'm just saying, excellent starting point, because if you're not sure what to do, this is what you do. Every single time. It has to go this way. Okay? Now, Oscar, we want to get from moles of carbon to carbon atoms. Yeah. Where? On top or bottom? On top. Because atoms of carbon to moles of carbon, well, the number has to go on top, because in 1 mole of carbon, exactly. Okay, now we got to know how to do this in our calculator, right? So let's make sure we can all do this. So get out your calculator there. Okay, and we're going to plug in 0.0038, right? top multiply, bottom divide. So we're going to have to multiply by Avogadro. So I have the 0.0038 times 6.022. Okay, that covers this part. How do I get the 10 to the 23rd in there? EXP. Good. Push in EXP. And then those little zeros show up in the upper right. Plug in 23. Hit equals. Okay. I'm going to report my answer to... We might as well stick with the sig fig thing. How many sig figs did I start with? 2. So I'm going to report my answer to 2. 2 point... What is that? 3? Yeah. Times 10 to the 21. Okay. 2.3 times 10 to the 21 carbon atoms. Make sure you can get it. Okay. So that's Avogadro. So if you do have a 6.022 times 10 to the 23rd molecules or something, I mean, how do you get that mass? For example, in this bag, I put in exactly, well, really closely within experimental error, 6.022 times 10 to the 23rd units of sodium chloride. That's what's in here. I massed it out. How did I know how much to put in there? Or in this bag of sugar, there's roughly 6.022 to the 10 to the 23rd molecules of sugar, right? So here's the hints on how I did it. Let's start with, how do you find the mass of a mole, or molar mass, same thing, of any element on the periodic table? What are those numbers? I don't know, look at copper. What is its molar mass? If you have 6.022 times 10 to the 23rd copper atoms, its mass is... It's the 63. It's the bottom one. It's 63.546 grams. So sodium chloride, right? The sodium is 22.9898. But I don't want just sodium. I want sodium chloride. I want a 1 mole of sodium chloride. The chloride is 35.45. So how would I get the molar mass of the whole thing? Just add them up. That's all we're going to do. So take the sodiums plus the chlorides, and you'll have it. All right? Sodium is 22.9898. And chlorine is 35.45. And I get 9898 plus 35.45. I'm just going to round it. I'm going to say 58.4. Okay. Sugar. Erica, how would I get sugar's molar mass? Here's sugar, C12H22O11. How would I get sugars? What would be the game plan for that? Atom, yeah. How many carbons do I have? 12. So take 12 times carbons. Look it up. You don't have these molar masses memorized for these elements. 12 times carbons plus 22 times hydrogens plus 11 times oxygens. And do all that without writing anything down. Your life is going to be so much less frustrating in this class. Right? So do it on your calculator. See what you get. 12 times fine carbon plus 22 times fine hydrogen plus 11 times fine oxygens. Hit equals. See what you get. Did you get 342? Okay. I think you're doing it right if you get 342, because several of us got it. Okay? So that's the molar mass of sugar. Okay, so we can write those numbers in here. The molar mass of sodium chloride is 58.4. The molar mass of sugar is 342. We need some units, though. And if you remember the units for molar mass, that's going to help your life tremendously. What are the units?
Is it grams?
Grams per mole. It's grams per mole. It's 58.4 grams of sodium chloride per mole of sodium chloride. 342 grams of C12H22O11 per mole. A lot of folks just write grams per mole, and that works too, but it's helpful to write the grams of the compound per mole of the compound, because it'll really help you with what's coming up. But it's always grams per mole. That number always goes with the grams. Okay, and we're not quite done yet, because we're going to mess with some terminology here. The molar mass of sodium chloride is 58.4 grams of sodium chloride per mole of sodium chloride, and may be referred to as, so you don't have to call it molar mass, although it's safe. You could also call it molecular weight or formula weight. Which one is it? Is sodium chloride an ionic compound or a molecular compound? If it's molecular if you don't see a what? Metal. Do you see a metal? Yeah, so this is an ionic compound. So that's a hint. Formula weight. They're just sticklers. That's job security with terminology. Just use molar mass, though. I think it's easier. Molar mass sodium chloride is 58.4. The formula weight is 58.4 grams per mole. Molar mass of sugar is 342 and may be referred to as... do you see a sugar? Do you see a metal? No. So this is actually a molecule. So molecular weight. I think it's a lot easier just to always use what, though? Molar mass. It's a lot easier, right? Then you can't get screwed up. But you'll see that. You'll see that. Some more terminology. 1 mole of sodium chloride consists of Avogadro's number, 6.022 to the 1023rd molecules or formula units of sodium chloride. What would you say, Diana? Formula units. Exactly, because it's not a molecule. 1 mole of sugar consists of 6.022 times 10 to the 23rd. Everybody? Molecules. Good deal. Okay. So you do this. Circle the molecular formulas and put a box around the formula units. So if you see a molecular formula, circle it. If you see a formula unit, put a box around it. Clarissa, A. Did you draw a box or you circle FeCl3? A box. Iron 3 chloride. Definitely, it's a metal in there. How about B? Annabelle. B as in boy. Box, because she sees sodium. Sodium hydroxide. How about Alejandro? C. You circled it. Carbon dioxide. Christian. Box. Calcium oxide. How about E? Danielle. Do you see a metal? Is there a metal? Both P and F are over there. All right? So if you see a metal, it's got to be ionic. It's got to be a box. But there's no metal, so you'd circle it. Well, how would you name this? Phosphorus pentafluoride, right? That's why you use those Greek prefixes. Okay. One more idea before we jump into the questions. One more helpful idea. You can write a lot of mole ratios just by looking at the chemical formula. So let's try it. We have iron 3 carbonate. We need to know the molecular formula of it first before we can write ratios. Daisy, what is the formula, the chemical formula for iron 3 carbonate? Fe, very good. With a little plus 3, right? Ooh, not Ca. CO. Yeah. Yeah. And what's the charge on the carbonate? Negative. Higher? 2. All right. So that's iron 3 carbonate. But what do we remember what you got to do with the charges? Put the 2 down there and the 3 out there. So it might look better if we erase it, but right there it is, iron 3 carbonate. So what we're after here, if I have 1 mole of iron 3 carbonate, how many moles of iron would I have? What would be the ratio? Can you see it? Right. Take out the mole and just look at the compound. If I have 1 unit of Fe2CO3, how many units of iron would I have? Where do you got to look? The 2. You got to look at that subscript to get it. Right? I actually have 2 irons. Think of it this way. If you're going to find the molar mass of this thing, you'd take 2 times iron, wouldn't you? So, yeah. So you have to have 2 irons. If you have 1 of those units, you actually have 2 moles of iron. 1 mole iron 3 carbonate. How many moles of carbon?
9.
How many moles? So you do this. You fill these in. Moles of oxygen. Right. How many moles of carbon? How many moles of oxygen? That's pretty much all the ratios that we could write. I guess we could flip them all, but it's kind of redundant. Allison, what did you say for the carbon ratio? 3. Very good. All right. How about the oxygen ratio, Melissa? 9. Everyone see where she got it? She took, all right, she multiplied those 2. She got the 9. Very good. Okay. So now we're ready for some questions. What is the formula weight of iron 3 carbonate? So I'll remind you what it was. Iron 3 carbonate. What is the formula weight of it to 3 sig figs? Right? So do it in your calculator, but don't do any rounding. Right? Find the molar mass or formula weight of iron 3 carbonate to 3 sig figs. So remember how to do it? Just add it all up.
So we would just, whatever we did here.
Well, no, right here. You'd have 2 times iron plus 3 times carbon plus 9 times oxygen to 3 sig figs. It's the last page, Melissa. It's missing. You have to write all these down. Yeah, it's the very last page. Sorry. They lost it. It's under the printer at the print shop. 3 sig figs. Anybody get an answer? Christian, you get an answer? 292. He says 3 sig figs. Everybody, Ellison agrees. 292. I see a lot of people shaking their heads. Okay, 292. But there's some questions coming up. There's a lot better way to write the 292. What units should we put on there? Okay, that's helpful, but not as helpful as it could be, right? That works, but what else could you say? 292 grams of iron 3 carbonate, and then, I don't know, it doesn't hurt. I mean, per what? Mole, keep going, of iron 3 carbonate. I mean, it looks like a lot of writing, but it's really going to save you a lot of time, I'm telling you. Okay, let's try this first one. How many grams are contained in 3.7 moles of iron 3 carbonate? So, Katrina, you've got 3.7 moles of iron 3 carbonate. They want to know how many grams there are. Where would you start? Yeah, the measurement. The iron 3 carbonate, yeah, but what's the measurement? Yeah, moles. And the number is?
The what?
The number? How much? How many moles? 3.7. So 3.7 moles of iron 3 carbonate. That's where I would start. Start with the measurement. Okay, Oscar, what's the first thing you should do here?
I would first put the 1 mole in the bottom.
Okay. And on top you'd put the
Avogadro's number,
Avogadro's number?
which is 6.02.
6.02. But they want to get to where though, Oscar? Do they want to get to units of grams? So this is how I suggest starting. Don't put any numbers there. Just put those units down there. Right? Just put the units. It's a real guide. And remember where you want to go, though. That's the other guide. You want to go to grams. It's staring at you on the paper what to write. The 292. It goes where? On the top. You're going to write this verbatim. You're going to use that conversion factor. 292 grams of iron 3 carbonate. See, by writing out all those units, it really simplifies things. It stares at you what to do. Do we quit now, though, or do we keep going, Erica? What units do you want to end up in?
Grams.
Grams. What units are we in right now? Grams. So keep going. Yeah, so stop. So stop. Report your answer to, I don't know, 2 sig figs, I guess, because that's all 3.7 has. Oh, this is a good one to report to 2 sig figs. All right? I can write down my answer. Way too many sig figs. How would you report that to 2 sig figs, Annabelle? How would you do that? Which would be what? Scientific notation? And you'd say 1 point. Well, you only want 2 sig figs, though. 1.1 times 10 to the 3rd. Very good. That's the best way you can write this. Okay. How many carbon atoms are present in 3 grams of iron 3 carbonate. So you've got 3 grams of iron 3 carbonate. All right, Clarissa, you've got 3 grams of iron 3 carbonate.
So we start with 3.2 grams of iron.
Yes, exactly. That's the logical way I'm trying to get you to get started on this. Because you could start in a lot of different locations, but you might start with the wrong thing on top, right? So just start with the measurement. 3 grams iron 3 carbonate. You may not see where to go, so just put what units where, Diana? What units have to go where? Cancel the grams of iron 3 carbonate. So they would have to, don't put a number down there, just put these units. And then you start asking yourself what to do. Well, you may already see what to do. I'm just saying that helps me. You want to get all the way to carbon atoms, Annabelle. I don't think we can jump from grams iron 3 carbonate to carbon atoms up here, but we can do what? We don't have a whole lot of choice. There's only one well, we'll put a 1 up here, but what conversion factor what am I talking about? The molar mass. It's the only thing we have to work with. So by putting the grams down there, you don't have much choice. Molar mass is all you have to work with. It has to be molar mass. So the 292 goes on the top or the bottom? It goes with the grams. Wherever the grams is, that's where the 292 goes. So it's going to have to go on the bottom. And that molar mass is defined for how many moles of iron 3 carbonate? What do I put on top? It's just 1. It's always defined as 1 mole per mole, right? 292 grams of iron 3 carbonate per mole of iron 3 carbonate. We just flipped it as all. Okay, we got to keep going though. We can't quit until we hit carbon atoms. So Alejandro, what do you think? Excellent. Don't put a number down there. Just put those units. And hopefully you can figure out where to go from there. Okay. Christian, where are we going to go from here? Want to end up in carbon atoms somehow. You still can't get there, but you can get where? Get a little bit closer. We can get from moles of this stuff to moles of what? Carbon. We can do that. I mean, we can't get to carbon atoms, but we can get this far. Right? What numbers do you put in there to make this ratio 1? To make it 3. Where do you, right? We did this once already. We said that you can look at this formula, and you can write a lot of mole ratios. You can write 3 moles of carbon for every 1 mole of this stuff. You can write 9 moles of oxygen, 2 moles of iron, right? Remember doing that? Okay. So that was just from the chemical formula. We're closer, though. So that's why we did the moles of carbon, because it's closer. At least we're in carbon now. We're still not there. Danielle? Yeah, so the mole of carbon unit has to go where? Has to go on the bottom. That has to go down there. Daisy, can we actually get to carbon atoms now? Yeah. Whose number is it? Avogadro. It's going to go on top or on bottom here? On the top, right. Because then 1 mole of carbon. And 1 mole of carbon, you have 6.022 times 10 to the 23rd carbon atoms. And 1 mole of anything, that's how many you have. So everything on top multiply, bottom divide. I would just disregard the ones. It makes it life a little bit easier. See what you get. That's what I got. And since I started with only 2 sig figs, I gave my answer to 2 sig figs. So hopefully you get that. 1.9 times 10 to the 22 carbon atoms. Okay, if you got it, go on and try D. If you didn't get it, just ask and let me help you out. Yeah, go on the next one. What did you get as an answer, Jonathan? Yeah, that's what I got. 3.7, 10, 23. So Jonathan and I got the same answer. I wanted to check with somebody before I wrote down the answer. 3.7 times 10 to the 23rd O atoms. Make sure you write units, otherwise you're going to lose a point. Jonathan and I got 3.7 times 10 to the 23rd oxygen atoms, so I bet you that's right. See, you can figure out E. Oh, I should have another sig fig, shouldn't I? 3.71. Thank you, sir. Thank you very much. 3.71. Did you get an answer for the last one?
Yes.
It's too big.
Oh.
That'd be the mass of 6.022 times 10 to the 23rd of them. That'd be like a bag of this stuff. Like, that's a lot. It's too big. You're halfway there, though. Okay. So is everyone on E? Okay, we only have a few minutes left, so let me just run through this quick. On E, there's a hard way and there's a logical way. The hard way, I think, is going through the same way we did it up. We have done it. We would start with what is boron trifluoride? What formula? BF3. You start with one BF3 molecule and convert all the way to grams. And it's not that straightforward. The logical way of doing it is find the molar mass of BF3, right? A boron and 3 fluorides. You find that molar mass. That's a mass of exactly how many BF3 molecules? Avogadro's number. So, for example, if you had 12 cookies, you know the mass of the 12 cookies. What's the mass of one? You just divide the mass by 12, right? Same thing with this. You find the molar mass of BF3, divide it by whose number? Avogadro. You're done. That's the mass of 1. So find the molar mass and divide it by Avogadro.
How many thick fish are we going to do?
Oh, I didn't even specify, so. So what was BF3's? Did you get a final answer, Christian? 1.126 times 10 to the negative 22. Anybody else get that? Okay, Jonathan got it. 1.126 times 10 to the negative 22. A really small number. It should be. It's one molecule. So I had to take boron, which is like 10.811, add it to 3 fluorines, 3 times 18.99. See what you get, divide it by Avogadro, you'll have your answer. Okay? So have a good weekend. Check out the chemistry help room, or come by and ask me some questions. Either way, we'd be glad to help.